go ahead and get started. So if you're taking your notes, I want you to stop right now. Remember, I want to see thumbs up or down if you're getting this or not getting this, okay? There's no real new math in here, okay? We're taking two things, we're putting in slope form, we're graphing them out. What's different now is that when we graph them out, we're describing what happens, okay? So we have a table and we have three options here. So looking at this first one, we have y equals x minus 1, and then minus x plus y equals 2. We have two linear functions. Are these both in slope form?
No.
No. One of them is, right? Because it's equal to y. So the very first thing we're going to do is we need to get this second one equal to y equals mx plus b, right? Because we need to be able to graph these out. So we're going to take this one. We want y by itself. We're going to do the opposite of minus x. We're going to add x to both sides. Then we're going to rewrite the problem. The x goes first plus 2 equals y. Any questions so far?
No.
Okay, let me see thumbs up or down. Okay, good. So that means these two are in linear format. We can go ahead and graph them out. Let's go ahead and graph this first one out. Where do I start, Adrian, on this one?
Negative 1.
-1, yes. -1 is our y-intercept or our b, right? So we're starting at -1, and what's my rise and run in this case?
Up 1 over.
Is it?
Down.
Down 1 over 1. Why is it down 1 over 1?
Negative 1 is negative.
Very good. And anytime we have a number, we always have at least a run of 1, correct? So from here, we're going to go down 1 over 1, up 1 over 1. That's our first line. Any questions? Thumbs up, down? Okay, good. So now we're going to move to the next one. We're going to start at 2, aren't we? And this time our rise in 1 is going to be 1 over 1 because it's positive. So we're starting at 2, we're going up 1 over 1. We graph those two lines. Let me see thumbs up or down on these two lines. Okay, guess what just happened here? We've covered this before. What are these two lines doing? Without looking at this, what's going on with these two lines that we've learned so far in this class? How do we describe that?
Parallel.
Very good. They're parallel. And why are they parallel? Yep, they're going the same. If they have the same slope, lines are parallel. Okay, so we're taking that, we're building upon it. Okay, there's three things that we're covering. So looking at lines that are parallel, the way we describe them, we use that word. They're parallel, and if a line's parallel, they have to have the same slopes, right? So let's look at this for a minute. Our slope is x, and our slope is x, right? So we know it's exactly the same. So that's what we do. We call it parallel, same slopes. We're done with the description, okay? Then we get the classification. They're parallel and they're inconsistent. Let's talk about inconsistent for a second. I wrote these words down to kind of give you a cheat word so you know what the word means, okay? So if something is an inconsistent system, it means that it has no solution. Now let me explain what I mean by no solution.
They're not ordered pairs.
No, they're definitely ordered pairs, but they don't intersect, right? They don't ever connect. That's what this matters right here. Okay, if they're inconsistent, they can never connect up, which means our very last thing, the number of solutions is none. Because these arrows go on forever. Okay, so that means they're never going to connect, so we call it inconsistent and none. We already learned parallel. We already know they have the same slopes. These are just the two new things, right? Inconsistent, they don't run into each other, and there are no solutions. Are we clear? So how we write this, our description, same slopes parallel, classification, inconsistent, number of solutions, none. Good so far? Let me see thumbs up or down, please. Okay, you want to be plugged in? Okay, good, good, good. Woo! Okay, let's look at the next one. This one's already in slope form, right?
Yes.
So we need to get this one in slope form. But notice there's something different in this one this time. We have numbers on both sides, don't we? We have a 0, we have a plus. Guess what? It doesn't matter. We're still solving the problem exactly the same way. So I'm going to take this problem, this one's already ready to go, and I write it. I'm trying to get y by itself, so I'm going to move this number. I'm going to do the opposite of plus 1. I'm going to subtract it from both sides, and then I'm going to rewrite the problem. 2x minus y equals minus 1. And then from here, I'm going to get the y by itself. I'm going to subtract 2x from both sides. I'm going to rewrite it. Negative y equals negative 2x minus 1. Can we have a negative variable? No. No such thing. We cannot have the negative variable. So we need to divide all this by negative 1, right? So this is negative 2 divided by negative 1. We're positive 2. And then negative 1 divided by negative 1, positive 1. So now we have these both in slope form. Can someone tell me what's going on with these two lines? Look at them real quick.
They're the same.
They're the same. Yes, very good, Fabian. So we're going to go graph this first one out, right? Levi says start at 1, and he's going to go up 2 over 1, and he formed the first line, right? Then you're going to go to the second line. You're going to start at that same one. You're going to go up 2 and over 1. They're exactly the same line, aren't they?
Yeah.
So if they're exactly the same line, we're following this on our table. So our description is they're the same lines, right? They have the same slope. They're consistent and dependent. Let's talk about this for a minute, okay? Notice how this one was inconsistent. They never ran into each other. These are literally the same line. They're on each other, right? If you have two lines and they're right on top of each other and they're the same exact line, they have to be dependent on each other. In other words, we have to have two lines for that to happen, right? So one depends on the other. Are we seeing that? Thumbs up, down? Okay. Last thing is, because these lines are right next to each other, or they are the same lines, as far as our solution, it's infinitely many, because they're going on forever. These lines are never stopping. If we have arrows like this, they're going on forever and ever and ever. Okay? Even once they get to ever, then they go further to everness. Okay? Are we clear? So, pretty straightforward. Taking two lines, graphing them out, seeing what happens. If the lines are parallel, we're following this. We're describing them parallel, same slope. They're parallel, inconsistent. There are no solutions. Looking at the lines together, they're same slope, same line. They're consistent. They're dependent on each other. There's infinitely many. Okay? Now we have one more left. Are either one of these in slope form? No. So we're going to start with the first one. We're going to get it in the slope form. We have y equals negative 3x plus 5. We're going to add 3x to both sides to get the y by itself. We always write the 3x first. So y equals 3x plus 5. Are we done with this problem? Yes, we can graph this one out, can't we? We have a b, we have a rise and run. Now we're going to do this next one. Okay? We're 2x minus y equals minus 2. We want to get the y by itself. We're going to add 2 to both sides. Then I'm going to rewrite it. I'm going to have a y up front. This is all I have left, negative 2 plus 2. I list the negative 2x plus first, and then plus 2, right? So now I'm going to graph them out. You guys are going to help me with this. Adrian, tell me where to start on this graph to graph this out. 5. Okay, so you're starting at the y-intercept of 5, and then what direction am I going on this line?
Up.
Adrian?
Up.
How many?
3.
And?
1.
Yes. So starting at 5, up 3 over 1, we graph this one. Fabian, help me with this one. Where am I starting at this line at?
2.
Okay, and what direction am I going now on my rise and my run?
Down.
Down, and what direction?
Over 1. Left 1.
To the right?
Yes, to the right.
Yep, to the right. Remember, if we drop a 1 underneath there, that 1 is positive. So now we're down 2, we're over 1, right? So we connect these two lines, don't they run into each other?
Yeah.
They run into each other. So we have this solution right here.
Different.
So our description, they have different slopes, right? One is 3x and one is negative 2x. Okay, so negative 2 and 3. We have different slopes. They're now consistent and independent. Let's talk about independent. They're independent of each other. That line's going to be there regardless. It's not sharing another line like this one, correct? Those two lines are sharing each other. So consistent, independent. Now guess what? When they do this, same thing that you did with elimination, same thing you did with substitution, all that stuff that we've been doing over the last couple of weeks, taking two lines and see where they intersect and what the ordered pair is, we only have one solution. They can only cross at one ordered pair, one x, one y. So that means there's exactly one solution. Is that clear?
No.
Who said no?
I said yes.
Okay, it sound like no. Okay, so you want to memorize this table, okay? Now we're going to use this table for 3 days. In 3 days, you should know it, okay? You need to know, after I graph my lines out, there are different slopes, right? If they're consistent and independent, there's exactly one solution. If the lines are the same, we state that. They're the same lines, the same slope, they're consistent and independent, there's infinitely many. Let me tell you how to get your brain to do this. These lines are going on forever, right?
Yeah.
They're never connecting to each other. These two lines are connecting, we know it's one. These ones are going on forever. These ones never connect. There's never a solution, okay? If you remember those things, you'll have this. So you're going to have problems. You're going to have to get them in slope form. You're going to have to graph them out. You're going to have to describe them, classify them, and tell me how many solutions there are. Not too hard, right? Let's talk about the do now. 3 questions, right? First one, in slope form.
Yes.
Second one in slope form.
No.
No. So we need to add the 3 to both sides, and we need to subtract the x from both sides, right? Get y by itself. This one is the first one in slope form.
No. Oh, yes, yes.
What about the second one?
No.
No, we have to subtract 3x from both sides, right? Look at this one. Is this one in slope form?
Yes.
What about this one?
No.
No. So get them in slope form first, graph them, because you have to graph them to see what's happening. Once you graph them, you're telling me description, classification, number of solutions. Are we good?
Yes.
No new math, right?
No.
No new math. Everything's the same. You're getting in a slope form, you're seeing what happens on the graph, Anna, and then you're telling me. So this table is important to you right now, right?
Yeah.
Okay, you want to get the do now done and turn it in. I will post the link down here for the YouTube link if you need to watch it again, okay? Okay, let me see thumbs up. Is there anything else I need to go over? We're all good? Emily, you're good? Awesome. Okay, get after it.
No, first,
Do the do now first, and then you can finish up your notes after the fact since you have a copy of them.